Jeremiah, the ladybird.
Oh, Jeremiah. Okay. All right, guys. So, okay. So, in these last few here, just trying to use kind of all our different properties we've been talking about, multiplication, division, negative exponents, kind of all the different pieces. What do you want to do first in 16?
Just multiply together.
Yeah. So there's nothing we can simplify inside, so we're going to distribute this 3 in. Everything's going to get that third power. So that's going to be a negative. Wait, how about the y's power?
Is it not x?
This is a 1, we're multiplying.
Oh.
So 3 times 1, right?
What was it that we were at?
When you had two different x's, like if you had x times x to the third, and then we add them. No, it's okay, it's easy to get those mixed up. How about y to what power? Negative 6, we're multiplying here, yeah, very good. All right, so I heard someone say negative 3 to the third is a negative 27, right? X to the third. What happens with the y to the negative 6? It's going to go into the bottom. Okay. Yes? Well, we don't have to solve it because it doesn't show anything. So no. Like they might substitute values at some point, but right now not. Okay, guys. How about number 17? Guys, what number 17?
Put the 0 in.
Okay, put the 0 in everywhere.
Yep. So it's gonna be 2 over 3.
No.
1 over 1, yeah.
Everything's getting that 0 power. So if anything's being raised to the 0 power, all of them are being raised to the 0 power. So they're all just going to become 1. It's going to be 1 times 1 over 1 times 1. It's just going to be 1 over 1. So if you were able to just say it was going to equal 1 right away or 1 over 1, that's great.
Yes.
Okay. Now number 18, a little bit tougher problem here. We have a lot going on here. So this second power can be distributed in. But if you notice, you can do some simplifying first. Do you want to do that? Or wait, or just distribute it?
Just distribute.
Just distribute. Okay.
Yeah.
What's up, Paige? Okay. So we can just distribute in if you want. You could have simplified first, but not a huge deal either way. 2 to the second, g to the fourth, h to the negative 4. On the bottom, 3 to the second, sorry, fourth. I was used to putting 4s on there. 3 to the second, sorry, g to the negative 2. Now this is being multiplied to this other fraction, so I'm just going to move that along. Now what do you want to do? Any thoughts?
Put them together.
Put them together?
Yeah.
Okay. So what we can do when we're putting them together, we can put the whole top together and then the whole bottom. That's fine. Some of you guys might want to get rid of negative exponents, up to you, but this is fine. We can multiply everything together. So on the top, 2 to the second is 4, g to the fourth, h to what power?
Positive 4.
Careful, we're doing these two. Oh, negative 1 over, I have 3 to the second times 4. 9 times 4, 36. G to what power? Negative 1. Okay. All right. 4 over 36.
9.
Where's the 9 going to be though?
Bottom.
Bottom, 1/9. How about the G? So this one's gonna go up. So I'm gonna have a G to the fourth and a G to the first, so G to the fifth on top. And then the H,
H to the 1.
that's gonna be on the bottom. Kind of a lot going on there. Okay. All right. So talking about missing exponents, this is just kind of trying to think about our different rules that apply here. So I have 4x to the question mark, 5x to the fifth, sorry. So what would the question mark have to be in this case?
5.
Why is that here?
Because you add them together.
You're adding the exponents. So in order to get that 10, it has to be x to the fifth and x to the fifth. 5 and 5 would be 10. So the question mark would be 5. How about this next one?
The question
Question mark would have to be a 3. Because in order to get 2 to the question mark equal 8, it'd have to be 2 to the third, m to the third, and then to the question mark to equal 9 would have to be 3. So the question mark would end up being 3. It's got to be the same thing in all cases. Question mark's a little late there. Okay. We're going to talk about scientific notation, and then we'll be done for today. So I'll kind of get you guys through this, finish our first section. Not have to take 3 days for it. So scientific notation is a way to show really large numbers or really small numbers. Do you guys remember how to do this? So we have 46 billion there. We some number times 10 to some power. So when we do this, we want a 1-digit number. So I used to explain it to my algebra students as we want like lunch money. So 46 billion is a lot for lunch money. But what would be a more reasonable amount using those same numbers for lunch money?
46.
4.62. So $4.62 would be a more reasonable amount for lunch money. So we're going to move that decimal place over and make this 4.62. Now, in order to move a decimal place over, I can multiply or divide by 10. This one, I want to multiply by 10 to make it much bigger. I want to make this a really big number, and I'm going to count how many times I had to move the decimal place. So it's way back here, so I go 3, 6, 9, and then one more.
10.
So it's going to be 10. Now your calculator is capable of doing these, or sometimes it even does it without you wanting to. If the number is too big, it'll put it in scientific notation for you. But scientific notation can also be used for really small numbers. So this is less than a penny. That's not lunch money. I can't buy anything with that. So how can I make 0.000085 into lunch money? Where do I want the decimal to be? 8.5. Now this one is a really, really small number. So instead of multiplying by 10, I'm really like dividing by 10. And how do I show that with an exponent? I make it a negative. I'm going to move this over 1, 2, 3, 4, 5, 6, is it? So a negative 6. So really small numbers, we use the negative exponent because it's really like we're dividing by 10, 6 times. So if I take 0.8 or 8.5 and divide by 10 6 times, that's the number we're going to get. All right. So multiplying and dividing with scientific notation works pretty nicely with our exponent rules. So what we're going to do is we're going to multiply the whole numbers, or the constants. I guess not whole numbers all the time. Or coefficients. So I'd multiply 3.5 times 2. So that'd be 7. And so if I'm multiplying and I have the same base, what do I do with the exponents? Add up. So 4 and 5 is going to be 9. that's now in scientific notation, 7 times 10 to the 9. Now the issue comes in when I multiply 7.8 times 3.2, and I get 24.96. It'll be times 10 to what power? The third, 5 minus 2. What's the issue with this, you guys? It's too big of a number. 24 is too big. If you spend $24 on lunch every day, I think your parents would freak out. So I would hope they would. So we want to make this number smaller. It needs to be a 1-digit number. So I'm going to make this 1 digit smaller. If I make this one smaller, it's got to be like a balance. I have to make this one bigger. So 2.496 is my new number. That's in scientific notation. And if I move this one smaller, this one's going to get 1 bigger. All right, and then finally division. And that's it. And then I'll explain what our homework is.
This is ringing some bells.
Yeah, I know you guys have seen it. So dividing the scientific notation, so divide the coefficients, the constants. But now with division, we are going to subtract the exponents. So 1.3 divided by 5. I get 0.026. Ten to what power? Yeah, it's going to be the 5th power. Because that 10 to the negative 1 can move to the top and become a positive 10 to the 5th. Or you could do 4 minus the negative 1, so that'd be a positive 5. What's the issue with 0.26? It's too small. You're not going to buy much with a quarter. So we need to make it bigger. So this is going to get bigger. So 2.6. That one gets smaller. Okay. Then finally, divide 5 by 2, you get 2.5. And then these, negative 3 minus the negative 7, or you can think about flipping. Like 10 to the 7 over 10 to the 3. So it would be 10 to the 4. And that one's fine. So your homework is listed correctly in Schoology. So what I have listed for your homework is I kind of picked and choose problems. It's a little bit of a mess. Sorry. The numbers don't go very well. I should probably just make like a worksheet or something, but I didn't. So I'll pull up the Infinite Campus assignment. So disregard what's on the paper. And you want to do what's this here?
They'll keep it for the rest of the life. Yeah, I think so. Adopt it.
We got these all and just feel better.
Is he still alive?
Yep.
You're a really good ladybug parent.
You're good dad.
I really don't like
That's Brian's fault.
Oh, you shoved it in my face.
No, I had to walk back.
Oh? Yeah, I was walking
Yeah.
by and you just shoved it in my face.
I
I cannot see him doing that.
I can't see them doing that. That doesn't seem like something you would do.
Oh, that's, yes.
Yeah.
Cut it fine, I'm gonna rip you off here. Sorry.